Assalamu alaikum wa rahmatullahi wa barakatuh. In this session, we will write Arduino code for this circuit. It is battery monitoring circuit, and it will cut off the battery when the voltage will reach at specific voltage level. We will write code step by step, and we will check it practically. When the voltage will reach at 13.4 volt, it will turn on this relay and it will disconnect the battery. It is protection circuit. I am using Arduino Uno board, and I am using this relay module to check it practically. So let's start. When the voltage are less than this voltage, it will turn off the relay. When the voltage will increase, it will turn on the relay and the battery will disconnect it. Let's check it. Basically, it is a question from my viewer from Saudi Arabia. He have this circuit and he need a software. He have this circuit with software, but now he needs software because the IC is locked and he cannot copy, and he don't have the copy of program. So he asked me to write a code for his project. So this is the practical circuit. Here it have two relays, this AC input circuit. Basically this circuit works in two methods. The first portion, that is relay number 1, it is used to detect the mains failure. If the electric is failed at that time, this relay number 1 will energize and it will start some security system, some alarm system, some lighting system, whatsoever. The second portion, that is relay number 2, that is battery level monitor. Because it is not powered on with the electric, it is powered on with standalone battery. He also sent me the diagram for this circuit. So this is the diagram. It has standalone battery system. So battery, 12 volt regulator, 5 volt regulator for this IC at Mega 328 IC. Here it is using ADC5, analog pin number 5 for the at Mega 328. Here I am not using standalone programmer or anything. I am using this Arduino Uno, and it is the same because you can program this IC in any programmer, universal programmer, but I will program using this Arduino Uno board. So ADC5, that is pin number 28 in the diagram, he is using to sense the input voltage, the battery voltage. Here is R11, R12, 4.7K and 2.2 kilo ohm resistor, and it is connected to VCC. That is wrong. It must be connected to the battery. So it will sense the battery. We will make correction here. After correction, this VCC will connect it to VCC 15 volts. So it is battery voltage. This voltage divider network, it will divide the voltage and it will give the portion of that battery voltage 4.7, 2.2. This voltage divider will divide the voltage and it will give to the Arduino A5 pin 4.7 plus 2.2, 6.9. This is RT. If we have 13.4 volts, divide it with RT, that is 6.9 kilo ohms, multiply with 2.2. At that time 4.2 volt will reach here. Our Arduino will reach 4.2 volt through this voltage divider network, and it will consider that the battery is 13.4 volt. Now I am using the same 4.7K and 2.2K, but physically when we connect resistors, what we need to do, we need to check the resistors practically for software coding. Otherwise it will not provide a good result. 2.2 kilo ohm resistor, it has 2.28, 4.71, 2.28, 4.71. These are the resistor values, 2.285 and 4.471. We will consider these two values, 13.4 volt divided with 4.471 plus 2.285. This is our total value. Multiply with 2.285. It will receive 4.53 volts. This is the difference. This is our ground. Now we will check the voltage. When the voltage are at 13.4 volt, this is our 13.4 volt. How much voltage will receive the Arduino? It is 4.4 volt. Okay, we will check the physical value, 4.4 volt. We will say 4.4 volt. This is our calculation. Let's move to the calculation. When Arduino will receive 5 volts, it will convert in digital format in 1023 bits. 10 to 3 divide by 5, multiply it with 4.4 volt. It is a 900 value. This is digital format value. When it will receive 4.4 volt, at that time 900 bits will receive to the ADC. It is ADC 5, analog input number 5. It is input. We will apply input at pin number 5, that is analog input, and we will say it is battery level. When we write code, always define some your own assumed names. That is very easy to understand. It will become very easy to write the code. A5, that is input pin, and it will monitor the battery level. We will name this parameter in the software that this is battery level. We will write the code. At that time, what will happen? It will receive a signal. At that time, it will receive a decision from PB1, that is pin number 15, to the relay K2. So pin number 15, this is in our format, and here is pin number 28 in the atmega. Drive the relay. So we will say charging relay drive. When we see the Arduino board, pin number 28, that is the 6 header, the last analog pins, the last pin, that is A5 pin. So we will say it is A5 pin. PB1, that is driving to K2. So PB1 in Arduino, PB1, that is pin number 2. Pin number 15 of this IC, it is connected to digital output pin number 2 because it is 10 pin header and it is IO high digital output pins. So these are 8 IO pins and 2 communication pins, RX, TX. So we will connect it to pin number 2. Let's move to the code. In the first step, this is integer. We will write A5. We will not use A5 pin in the software. We will use battery level. Battery level, which we defined here, we will define a name to our parameter. This is A5 pin, that is analog input number 5 pin. So it is A5, battery level monitoring. The second parameter, that is charge relay, that is connected to pin number 2 here. A5 terminator colon, and in the comment we will write battery level monitoring. Integer charging relay is equal to number 2, that is pin number 2, to drive the battery charging control relay. This will not run in the setup. This is our own definition, and we will use these names. We defined some names, and these names we will use in the calculation in the software. In the setup, we need to define the pin role. What is the role of the pins? Because it's all pins are general purpose. We can use as an input, we can use as output. So we are defining pin mode. PIN-MODE, pin mode, battery level. Why we write battery level here? We can write A5, but we will use the name battery level as we assume X is equal to this, Y is equal to this. So this is the XY. X, Y, Z, A, B, C, any one name for our understanding. So this name is very closer to our required function, that anyone see this code, he can understand that it is battery level monitoring. Battery level, that is input pin. Battery level is equal to A5, analog number 5 input. Then pin mode, charging relay. Charge relay, that is output pin. Anyone will see this code, he can understand that this is the output pin. No need to write comment again. Here already we written this comment that charge relay, this function will define that it is to drive the relay. Okay, let's see the program. Void loop. This code will run again and again and it will monitor the circuit all the time. Loop. Now we need to use this integer, battery value. We are assigning this name for our calculation. Battery value is equal to analogRead. This analogRead is a function for Arduino, that when we are taking signal, read signal, write and read signal, analog, that means analog pins. AnalogRead, which pin? Battery level. Battery level is A5. The battery value which we are measuring from A5 pin, it will equal to how much voltage we read battery level. This will equal to the battery level, this value. Float. This is the calculation function. Battery level, this is the same battery level which is here, is equal to 1023 steps. 1023 steps, these are for 5 volt. Multiply with battery level. How we will put the battery level voltage in our calculation? Ground. And first of all, set the battery level where you want to adjust. For example, I want to adjust at 13.4 volt. At this level. Now measure the voltage which we are feeding to the Arduino. 4.397, 4.4 volts. Type here 4.4. 1023 divide by 5 multiply with 4.4. It is 900. So we are using this 900 value. Here we will write 900. The battery value is equal to analogRead battery level. This is our A5 pin. Which voltage we received from pin number 5, that will equal to battery value. Okay. Float. Battery level is equal to 1023. The same formula, the same equation here. Divide by 5, multiply by battery value which is here, which we read from that pin. It will equal to battery level. If battery value is less than 900, which we calculated here, now we are calling if else function. If battery value is less than 900, that is here, what it will do? digitalWrite. This is next function now. At Mega 328 IC processor, it will check if the voltage are less than this value, because we are feeding analog voltage and it is converting in digital equivalent value 900. That is inside processing. After processing, if the voltage are, if the number is less than this, it will turn on the relay. In our condition, because this relay have inverted signal, and if we see the LED, if we monitor the LED, this time the LED is on, the output is high. In this relay module, when the output is high, at that time it will turn on the relay. Otherwise the relay will off. You can use common and normally closed point to charge the battery. When relay will on, it will disconnect and its point will shift it. Now the LED is on. If the voltage are less than 900, if the voltage are less than this, the LED is on. If we have voltage above than 13.4 volt, the LED will turn off. We can see if the voltage are less than this, the output will high in our relay condition, because relay will work inversely. Here the output is high and relay will remain off. When the voltage will increase, at that time the relay will turn on. Yes, it is turned on now. Now in our this condition, the voltage, this 900, it is equal to 13.4 volts. digitalWrite. Charge relay high. As we see here, the LED will turn on. Okay. If the voltage are less than this, the relay will on. If the voltage are above than this, then it will use else function. Else digitalWrite charging relay terminator. Remember, always you need to use colon sign, that is statement terminator, in end of every statement, otherwise it will receive errors. And always use braces for any block. In else block, this is the starting bracket and this is the ending bracket. And here we see in if function we have also braces. We defined if battery value is less than 900, at that time charging relay will high. At that time this relay will active and it will shift the points and it will turn off the battery. So this is the code. After writing your code, sketch, compile, there are no errors. After that, upload. Now the program is uploaded, and when the voltage are above than that level, 13.4 volts, we can see less than 13.4 volt, the relay is off. The battery is charging. When it will exceed from 13.4 volt, the relay will turn on. If you have some calibration issue, you can adjust this value for the battery value. For example, we want to turn on exactly 13.4 volt. This time our calculation is 13.48. So we want to monitor at 13.4 volt. This is our exact 13.4 volt. So let's adjust some value, some numbers in the software. Now 890, we will write 890, compile it, upload it. We can see at 890, decrease the voltage and adjust it again to check its function. Yes, at 13.35. So we will write 895 and we will check its switching point again, upload it. Yes, the sketch is uploaded. Decrease the voltage value and increase again. Yes, it is now exactly turning on at 13.4 volt. So in this way we can calculate, we can calibrate this software. 895, that is the exact code for this battery level. If you want to adjust at any other value, just use the voltage divider network and check the voltage value here, what is at that time, 4.389, because we considered 4.4 volts. So if you will use the exact value, you will receive the exact results. In our next session we will check mains failure detector. That is the portion of this circuit. We will check this optocoupler circuit and the drive of this K1 relay. This is the idea to write the code for any circuit. Just see the diagram, how this circuit is working. We will write the code. I hope so you enjoyed this video. If you enjoyed, hit the like button. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.